All right, so first one we got sine by itself. We're going to obviously simplify the left-hand side. I have sine is a common term between both of them. So I'll go sine theta by factoring out. We got sine squared theta plus cosine squared theta. We want to get to sine squared plus cosine squared because that is our Pythagorean identity, which is then going to become 1. So we got sine theta times 1. Sine theta equals sine theta. Okay, Pythagorean identity is going to help us. Looking for squares and addition. Those should come up. We then simplify. Number 2, a couple ways you get to it. First way, I could split the fractions and go 1 over secant squared t minus secant, oops, there it goes, minus secant, there we go, secant squared t over secant squared t. That never happens, okay? What's 1 over secant squared? Cosine squared t, that's going to be minus 1. Now, in your Pythagorean identities, sine squared plus cosine squared equals 1. If you move it around, that is not sine squared. But if we took a negative 1 out of it, it's now 1 minus cosine squared t, which is then negative sine squared t. So we need. If you didn't want to split the fraction, 1 minus secant squared is what? I think it's negative tangent squared. I believe it's secant squared minus 1 when you do the Pythagorean identity with tangent. So then that gets you then secant squared still on the bottom. Then it's negative tangent squared t times 1 over secant squared t. I guess my handwriting's still excellent. There we go. Now you're just going to look at the ceiling. All right. So now we got sine squared t over cosine squared t times, what's the reciprocal of secant? Yep. It's cosine squared t. Reduces down to leave you with negative sine squared t. Okay? Another way to get to it. 3. Think of 2 theta as theta. It's a variable. The 2 is not affecting it. It's just another way we can name it. So what I could do is I could distribute in this term on the outside to both tangent and cotangent. So we're going to go sine 2 theta cosine 2 theta times tangent 2 theta plus sine 2 theta cosine 2 theta, cotangent 2 theta. Now, tangent is sine over cosine. Cotangent is cosine over sine. We bring down the rest of them. Do you start to see where we're going to go next? Okay, now I got cosine and cosine reduce out. I'm left with sine squared 2 theta. On the second part, I have sine and sine reduce. I'm left with cosine squared 2 theta. This is Pythagorean identity. It's 1. 1 equals 1. Number 4. What's sine squared plus cosine squared? Okay, so we got tangent squared 2b plus 1. And then tangent squared plus 1 is also a Pythagorean identity. It's secant. So you do 2 different Pythagorean identities to simplify.
Is there a different way to do that one? It's like off the top of your head. Can you see one?
You're going to have to get rid of the addition. And really our way to get rid of addition so far with the identities that we have is by using the Pythagorean identities. You could make fractions with common denominators, but
That's what I did.
I think that's the far quicker route on this one. Okay, 5, I'm going to take secant squared x out of both. Leaves me with 1 minus sine squared x. 1 minus sine squared x is what? Yep, cosine squared x. Then I have secant is 1 over cosine squared times cosine squared x. So we then have cosine squared x over cosine squared x, and you get 1. Number 6. This one's tough to see, I admit. My approach here is I'm going to take sine squared and say what it is equivalent to. By the Pythagorean identity, it is 1 minus cosine squared k. Well, then when I put it in, I now have the 1's there. So that's what actually gets me the 2 minus cosine squared k. And it's different because we're not thinking of it now as why do we suddenly have this 2? It can't be Pythagorean identity. It's just, well, it's 1 plus 1 is 2. We could split them apart or put them back together to get to it. Seven, I look at this one, and I have cosine A plus sine A times sine A over cosine A. That's going to give me a fraction in the second part of sine squared A over cosine A. Now, I want to add these two fractions, or add these two values, because on the right-hand side, I just have a secant, no addition, a single term. So by adding them, I can combine them to a single term and see where we simplify. Now, to make them have common denominators, I have to multiply the top and the bottom by cosine. Now they match. I can combine them. 1, well, it becomes cosine squared plus sine squared, which is 1, over cosine A. And then the reciprocal of cosine is secant A. Number 8. Are we on timer? I have 2 minutes. Better go fast. Okay, number 8. I look at the left side as a binomial squared. It's going to be 1 plus 2 tangent theta plus tangent squared theta. That is going back to if I had something like x plus y squared. It's x squared plus 2xy plus y squared. You could use FOIL if you use 2 terms, or you could use the box to multiply. But once I have that, what's nice there is I have this 1 plus tangent squared theta plus the 2 tangent theta. And I need that 2 tangent theta for the right side over here. Well, 1 plus tangent squared just becomes secant squared theta plus 2 tangent theta. Number 9, we have tangent is sine b over cosine b. Cotangent is cosine b over sine b. I need to get like denominators. So the like denominators for those have to be cosine times sine. The way I'm going to get that is I'm going to multiply the first fraction by sine over sine, and the second fraction by cosine over cosine. What's nice there is I then have sine squared plus cosine squared. Maybe. Which becomes what? What's the top? Yep, 1. And then from there, it's the reciprocals of both. Reciprocal of cosine is secant. Reciprocal of sine is cosecant. I'm going to take the right fraction. Have that. What do I do next? Yep. 1 over cosine x minus sine x, which becomes secant x minus sine x.
Bet you got